Hey guys, welcome to the channel, and if you're new here, please consider subscribing. It doesn't cost you anything, but really will help the YouTube channel grow. And today we're going to be making the heating chamber for the injection molding machine. So to come up with the final design, I 3D printed a few models. This is only two of the models. I actually made quite a few of these. But the major thing was the actual plunger size over here. This is about a 20 mil over here. You can see it's quite big, and this is a 17.5 one. And yeah, as you can see, the nozzle then screws in the top here, just to finish it off. And then you got the two holes for the sensors to go in on the side over there. So looking at the actual design here, hopefully this lighting is a little bit better. I came up with this broad design, but the main actual reasoning was I settled on 17.5 chamber size inner diameter of the chamber. And the reason for that is that because we're using an M20 bolt here as the nozzle, it can basically, this is the size you have to drill to be able to thread the M20. And then I could basically just drill straight through it. Don't have to play with the chamber sizes over here, and that'll go through. It has another advantage of that obviously the chamber will require less pressure because it's obviously smaller to be able to push the shot of plastic down here. Obviously the downside is it's going to be a smaller plastic volume that you can push out here, but I think I've settled with that, and yeah, that's going to be the final design. Now to actually make the final design, it's this piece of stainless steel here, and it's actually freaking heavy. I don't know how heavy it is. I don't have a scale on my normal scale that I use. It actually bottoms out or errors out. But I managed to get this for actually quite cheap from a supplier. I didn't have to buy the full length. I just went there and asked for offcuts, and they had this offcut. So I bought this offcut, so maybe that's a tip there. When you go to these places, ask for offcuts, and that you don't have to buy the full length. At a huge cost, and you buy this, like I say, it was almost virtually nothing that I paid for this. So let's go over to the lathe. I'm going to obviously face off, and then I'm going to drill through this stainless steel, and then start basically turning it down to the required diameters. Now obviously this diameter is very big, but due to, you can see over there, the size there, I don't know if that's going to be that evident, but there's going to be quite a bit that has to be turned down to get to the final diameter to make this. And so as you can see, that's I would have preferred to obviously get a closer, diameter here. So let's go over to the lathe and let's make this. Okay, and now what we end up with is this, and yeah, that's what it looks like with the threaded on that side over there. And I'm going to be quite honest, I didn't thread the whole thing in the lathe using a tap. I just started off, then moved it over to the bench, put it in a vise, and then the tapping. This stuff is hard. And then yeah, I've got a little brass washer here. I don't know if that's going to be necessary, but I just did add it, and that'll then obviously just screw in there for the nozzle. And then I cut a heat break in here. I don't know if that's actually deep enough and it's going to serve any purposes. Maybe you can leave a comment below and let me know what you think about this heat break. And then the elephant in this video is going to be these holes over here. Now what you'll notice is these holes are supposed to be, I think it's an M4 bolt that has to go in here. And the interesting thing about this bolt is, here's the sensor over here. This thread that goes on the sensor is not a point or one pitch. It's a 1.25 pitch. Let's just get the gauge out here. So using the thread gauge over here, that thread is 1.25. I don't know if you're really going to be able to see that. So normally it's 1, but this is 1.25. So I'm going to leave a link to the tap that I actually used in the end. It's an affiliate link. If you do buy it from them, I will get a small percentage, I think. But yeah, it's not your standard tap. And you're also going to notice that this is broken over here. And the reason for that is when I try to tap this thing, this chamber, the stainless steel is extremely hard. And to tap with such a small tap didn't actually work. So I ended up having to drill these holes bigger. And then I was going to use a bolt like this and then drill a hole through it, which I did over here, and then tap it. But as you can see, I don't know if you can see that, but the tap broke off inside there. And I did it again there. I was going to weld that on there and then be able to tap it there. So what I've settled for in the end is I'm going to make brass inserts over here, push them in, because brass is obviously going to be a lot easier to tap. Then do a press fit in here, and then then thread the sensors in here. And the reason why these sensors break, or this here it breaks, is it's actually very flimsy, this connection here. Is that once it goes in there, if you just tighten slightly, it's actually just got to be tightened with your hands. If you go anything with a spanner, it'll just break immediately. So I've got to obviously order another 2 of those. A little bit of school fees there. And yeah, let's go and make the press fits and let's see how that works. Then I'm going to get the brass inserts out the fridge, one at a time. I'm not actually going to heat the chamber. I was going to do that, but I think I'm going to put a little bit of Loctite, permanent Loctite on the inside of this with an earbud, and then push them in here. Now the correct tool to actually use to do this is an arbor press, but I don't have that. So I'm going to try to do it on the vise, and hopefully that works out. Okay, that's after the inserts have been installed. I haven't left it, or I haven't made it flush here, so that basically the temperature sensor, that'll actually have a little bit more place to be secure on. Did give it a slight little file on the top there just to round it off, not necessary. But one thing to be mindful of if you do this is that obviously when the heat bands come over here, there's that bar that goes over there. That cannot, make sure that that's not going to interfere with that bar, otherwise you're going to have a problem. You would have to then file this flat, turn the heat band the other way around, drill a hole through. But we'll cover that later when we actually put the heat bands on. So that's what it actually looks like. I think it's a good solution in the end. The heat sensor will actually touch chamber. So all these copper or brass inserts are doing is allowing for a threaded surface for the actual sensor to sit on. And like I said, it was virtually impossible to use an M4 thread to thread into these things. First of all, the hole is too shallow, Even if you do have a blind tap, I don't know where you'd get that from with that pitch on. This worked out actually very well. Just push them on, and yeah, that's that. But let me know in the comments below what you think, or what other opportunities or other solutions I could have come up with here. Just hoping that the extra stuff that I put in that thread lock, the permanent one's going to help, although it may not help because of the heat that on the chamber. It might, just make that, not have any function whatsoever. But I think the press fit, it's going to be strong enough, but time will tell. So guys, that's the construction of this heat chamber. And let me tell you, it was not easy to make this little thing over here. That's with a nozzle in it over there. That's basically what it looks like. Not easy to make. This stuff is extremely hard. I think it took about, I'm not going to lie to you, 3 hours to drill through this thing and complete it. But yeah, it's done. So let's move on to the next step, which is going to be the plunger. I'm either going to make that out of stainless steel or brass as well. Probably brass, because it's going to obviously not allow it to get stuck in the chamber. And well, that's what I'm hoping. It's obviously a lot easier to work with. And if it'll wear, because it's going to be obviously softer than the stainless steel chamber, so if anything wears, it'll wear. It'll be easy to make again and then just replace. So please join me in the next video. Oh yes, and don't forget to like and subscribe, and see you next time.